So when you have radical equations, those would be equations with radicals that have variables within or underneath that radicand, or underneath the radical. So in the radicand, you've got your variable. So for solving these, if you've got something else over with the radical expression, you want to isolate that to just being the only thing on the one side of the equation. And then after that's isolated, we're going to eliminate the radical by raising both sides of the equation to the equivalent power. So in your example, this is a cube root, so you would raise both sides of the equation to the third power, and that would undo or eliminate the root. Then you just solve for the variable. That gets you to the stuff inside. So in example 1, remember when you don't see a root or an index, it is a 2. So that is the only thing on that left side. So we can start right away by undoing the square root by raising both sides to the squared power. So that purpose on that left side is to cancel out the root and get you to the inside stuff. So that leaves you with x plus 3 equals, and then 7 squared will be 49. So now you just have a regular equation. You can subtract your 3 over. So x equals 46. So similar with number 2, you've got the fourth root now of p plus 5. Nothing adding, subtracting, multiplying with that. So the very first step is raising both sides to the fourth power. Cancels the root. Actually evaluate or get what negative 2 to the fourth is on the right side. So 16 equals p plus 5. Subtract your 5 over. So for number 3, this part here is your root. So before we can square both sides, you would want to isolate that by moving the 4 over, then undoing that root. So we're going to subtract 4. You have the square root of 3x minus 2 equals 1. Now, a square root, we're going to square both sides. Cancels the root on that side, leaves you with just the part underneath, the radicand. 1 squared on the right. And then just solve for your x. So add 2 and divide by 3. Let's do 5 and 6. So for number 5, this is the part in your root. So we're going to, before we undo or eliminate that radical, we're going to move the 16. So we have the square root of x equals 20. Now the radical is the only thing on that left side. So we undo or eliminate that by squaring. It's an equation. So whatever you're doing on that side, you got to do on the other side. 20 squared is 400. Square root x squared cancels, leaves you with just x. So there's actually nothing to even solve for here. Like literally x was just inside there, so x will equal 400. Remember, you guys can always check these. Like it's still just an equation. So if you're thinking like 400 seems really weird, well, plug it in the calculator. Check, is 400, square root of 400, minus 16 equal 4. You can always check your answers. All right, and then your last one here. 2 plus 3 times the fifth root of x minus 2 minus 7. So keep in mind, these two, the numbers 2 and 3 are sort of separate. Like 3 is attached or multiplying with that fifth root of x minus 2, so it's not just a 3. You can't just say like 2 plus 3. You got to get rid of them separately. So we need to subtract 2. And then when you have 3 times the fifth root of x minus 2 left, it's 3 times that. So we want to divide by 3. So we've got to get rid of that 2 and 3 separately. You can't add them together. Not really like situations. So 5th root still of x minus 2. Negative 9 divided by 3, negative 9. We've got a 5th root. So we're going to eliminate that by raising both sides to the 5th power. Keep it equal. It's an equation. 5th and power of 5 cancel. Gets you to the x minus 2. Negative 3 to the 5th is negative 125. Add your 2. So we're just getting the root or the radical expression to be the only thing on the one side of your equation. And then you eliminate it by raising it to the same power. Just don't forget to do it on both sides of your equation. Got to keep it equal.